In this video, we're going to take a quick look into the world of deep learning. Even if you're new to the field, don't worry, I'll be breaking down the concepts step by step and give you an easy-to-understand example to help you get started. Let's dive in and see how deep learning can be used to make our lives easier. You all have probably heard of artificial intelligence and machine learning. If not, I will highly recommend these videos, which are on the top right-hand corner on the screen right now. But what is deep learning? Are they all related? Yes, they are. Let me explain. Deep learning is a subset of machine learning, which in turn is a subset of artificial intelligence. Artificial intelligence is a technique that enables a machine to mimic human behavior. Machine learning is a technique to achieve AI through algorithms trained with data. And finally, deep learning is a type of machine learning inspired by the structure of the human brain. Ever wondered how Google translates an entire web page to a different language in a matter of seconds, or your phone gallery groups images based on their location? All of this is a product of deep learning. But what exactly is deep learning? First, let's understand the meaning of these two words individually, deep and learning. Deep can refer to the distance below a surface or the level of intensity of an emotion or feeling. It can also be used to describe something that is complex or profound. And learning refers to the process of acquiring knowledge or skills through study, experience, or instruction. If you put these two words together in context, it describes something amazing. Deep learning is a way for computers to learn and understand things, just like how we humans do. Think about our brain. It's like a big computer that helps us see, hear, talk, and understand things. Just like our brain, computers also have something called a brain, which helps them understand things. It's called a deep neural network or deep neural learning. A neural network is like a big puzzle with lots of pieces, and each piece is called a neuron. These neurons work together like a team and help the computer understand things. When we show the computer lots of pictures, it can learn to recognize faces in pictures, understand what people are saying, and even drive cars by itself. It's like a magic brain that helps computers understand and do things just like humans. Deep learning is a branch of machine learning that is characterized by the use of deep neural networks, which are composed of multiple layers of artificial neurons. The term deep in deep learning refers to the large number of layers in these neural networks. But what is the difference between machine learning and deep learning? In traditional machine learning, algorithms are used to extract features from data and use them to make predictions or decisions. The computer is programmed to look for specific patterns in the data, and it uses these patterns to make predictions or decisions. Deep learning, on the other hand, uses neural networks to automatically extract features from data. Automatically is the word that we emphasize when describing deep learning. A neural network is made up of multiple layers, which are connected to one another. Each layer performs a set of computations on the input data, and as the data moves through the layers, it extracts more and more complex features. This allows the neural network to make more accurate predictions or decisions. The first layers of a deep neural network learn simple features, such as edges, textures, and shapes. As the data progresses through the network, the layers learn increasingly complex features, such as parts of objects, and entire scenes. This hierarchical feature extraction allows deep learning models to perform tasks that are difficult or impossible for traditional machine learning models, such as image recognition, natural language processing, and decision-making. One of the main benefits of deep learning is that it can learn from a lot of data, so the machine can understand multiple levels of information, which allows them to learn complex patterns and generalize better. Applications. Deep learning models can be used in areas such as computer vision, speech recognition, natural language processing, robotics and control, healthcare, and financial services. Google Translate, for example, uses deep learning-based NLP models to automatically translate text from one language to another. The system is trained on large datasets of text in different languages, which are used to teach the network how to understand and generate different languages. Once trained, the system can translate entire paragraphs of text in a matter of milliseconds, making it a powerful tool for people who need to communicate across language barriers. Another example of deep learning application is in recommendation systems. For example, Netflix and YouTube use deep learning-based recommendation systems to figure out our taste in movies and videos and provide us with personalized recommendations. These systems analyze our watching history, likes, dislikes, and other data to understand our preferences and make suggestions. Finally, in the field of self-driving cars, deep learning is used to develop object detection systems, which can identify and respond to other vehicles, pedestrians, and traffic signals on the road, as well as other modules such as lane keeping, traffic sign recognition, among others. Deep learning, the mysterious mastermind behind some of the most impressive technological advancements of our time. From image recognition to natural language processing, deep learning has been the driving force behind it all. But just like any superhero, deep learning has its own set of limitations, such as data. Deep learning models rely heavily on large amounts of data. The limitation of data can be a barrier to the performance of deep learning models. For example, if a model is trained on a small dataset, it may not generalize well to new examples and will have a high variance, meaning it will perform well on the training set but poorly on unseen data. This is known as overfitting. Another limitation is training time. Deep neural networks take hours or even months to train. The time increases with the amount of data and number of layers in the network. But don't worry, researchers and engineers are always working behind the scenes to make deep learning more accessible and understandable. Frameworks. The most popular deep learning frameworks include TensorFlow, PyTorch, Keras, HAF. These deep learning frameworks are software libraries that provide a set of tools and pre-built functions to make it easier to train and deploy deep learning models. And just when you think you've seen it all, deep learning continues to surprise us with new and exciting applications. Who knows what deep learning will come up with next? So stay tuned, because the future of deep learning is deep and definitely worth keeping an eye on. And remember, with great power comes great responsibility, so let's use deep learning for good. Thank you for watching, and don't forget to subscribe for more videos.